Hi, today I'm going to be teaching AS Level Further Maths under the Edexcel specification. I'm doing the core module, and today I'm doing chapter 6, which is matrices. So first I'm going to introduce matrices. So a matrix is a set of elements within a pair of brackets, and a matrix can be referred to as n times m, where n is the number of rows and m is the number of columns. So for example, we have a matrix where 1, 2, 3, and 4, that's a 2 by 2 matrix, and then we have one where it's 1, 2, 3, 9, 8, 7, and that's a 2 by 3 matrix, because in this one there's 2 rows but 3 columns. So a square matrix is a matrix where n is equal to m. So for example, you saw the 2 by 2 matrix, that's a square matrix because they're both the same. A zero matrix is where all of the elements are 0, and that is denoted by the number 0. And an identity matrix is a square matrix in which the elements on the leading diagonal, which starts on the top left, are 1, and all remaining elements are 0. It's denoted by I with subscript k, where k is the size. So there we have I3, where it's a 3 by 3 matrix with a diagonal starting in the top left of 1, and everything else is 0. So now I want to talk about matrix multiplication. So now I want to talk about matrix multiplication. So matrices can be multiplied together if the number of columns in the first matrix is equal to the number of rows in the second matrix. The product matrix will have the same number of rows as the first matrix and the same number of columns as the second. But the order in which you multiply matrices is very important, because let's say, for example, you have matrix A and matrix B. The multiplication of AB does not equal to BA, and even if AB exists, BA may not, because the number of rows and columns have to be the same for them to be multiplied, and that may be the same for one way round, but it might not be for the other. So to find the product of two matrices, you multiply the elements in each row in the left-hand matrix by the corresponding elements in each column in the right-hand matrix, and then you add the results together. So you see here, there is a 2 by 3 matrix times by 3 by 2 matrix. And you see each of the corresponding things. So the first row times by the first column, and that equals to the top left answer in the new created 2 by 2 matrix. And that happens for all of them. So the first row is times by the first column, then the second column, and then the second row is times by the first column and the second column. And that is how you make the 2 by 2 matrix, and that's how you get the results. You can also do this a lot faster in the calculator. So on the CG50, which is what I use, you go into run matrix, which is the first thing, and you go into math. So you see there's the options jump, delete, mat, VCT, or math. So you press F4, which is math, and then you go into mat/VCT, and you see there are some preset matrix sizes, or you can do n times m. So you can get any size of matrix you want, and you input the size, and then you input the numbers, and you can do it a lot faster there. This is the way you do it in theory. Okay, so now I'm going to be talking about determinants. So you can calculate the determinant of a square matrix. The determinant is the scalar value associated with that matrix. So for a 2 by 2 matrix, M equals to A, B, C, D, the determinant is AD minus BC. If the determinant M is equal to 0, then M is a singular matrix. Whereas if the determinant M does not equal to 0, then M is a non-singular matrix. And singular matrix means it does not have an inverse. So you can calculate the determinant of the 2 by 2 matrix by AD minus BC, but also if you want to do it on your calculator, you can, so I've already told you how to input a matrix, or you can do it from the mat VCT and input it that way as matrix A. You can do it both ways. But then you can go into options. So from the main run matrix where you have your first set choices, you press option, and then mat VCT, and you can press det, which is determinant, and you can either do det and then press mat, and then alpha, and then the letter of. So to find the determinant of a 3 by 3 matrix, you must reduce it to a 2 by 2 matrix. And you do that by forming the minors of the elements. So the minor of an element in a 3 by 3 matrix is the determinant of the 2 by 2 matrix that remains after the row and column containing that element have been crossed out. So for example, you want to find the minor of, let's choose A. So you see A there. So we cross out this and we cross out this. And what's left is E, F, H, and I. As you can see, there is E, F, H, and I. And so you have, in this case, I've chosen A, B, and C to do my minors off of, but you can choose any row or any column in the matrix to do it from. But you have to remember that it's plus A minus B plus C. And that is because if you see at the bottom, there's the lattice of plus and minuses. I go more into that later when I'm talking about inverting a matrix. But basically, so when you're doing the determinant of a 3x3 matrix, you have to imagine that, so it starts from the top left is plus, and then minus plus, and it alternates like a chessboard or something. And this goes for any size of matrix. It just works better for 3x3 because you can visualize it here, and I've written it out, but it works for any size. It continues. So yeah, you have to remember that some will be plus and some will be minus. So for this, it's plus A minus B plus C. But for example, if you're doing D, E, and F, it'd be minus D plus E minus F. So now I'm going to be talking about inverting a 2x2 matrix. So you can find the inverse of any non-singular matrix, which means the determinant is not equal to 0. And the inverse of a matrix M is the matrix m to the power of minus 1, such that m times m to the power of minus 1 is equal to the identity matrix, or I. So if m is equal to A, B, C, and D, then m to the power of minus 1 is 1 over the determinant of m, D minus B minus C, A. So A and D are swapped, and B and C are both times minus 1. So for example, if we have matrix A, 3, 2, minus 1, 1, the determinant's 5. So the inverse of A, or A to the minus 1, is 1 over 5, 1 minus 2, 1, 3. And if you want to do this on a calculator, you get up your matrix, whether you've input it or you just write it out, and you just do it to the power of minus 1, and that gives you the inverse of the matrix. It's also important to note that if A and B are non-singular matrices, then AB, the whole to the power of minus 1, is equal to B to the minus 1 times A to the minus 1, instead of the other way around, because it's the total inverse. And if you remember, it's important the order in which we multiply matrices together, because they create different solutions. Okay, so now I'm going to talk through inverting a 3x3 matrix. So first I'm going to define transpose. So the transpose of a matrix is found by interchanging the rows and columns. For example, if A is 1, 4, 2, 3, then A transposed, or AT, is 1, 2, 4, 3. And so I want to show this on a 3x3 matrix as well, because the way it's defined doesn't really describe how to do it. So there's a matrix where it's 1, 2, 3, 4, 5, 6, 7, 8, 9, and it transposed basically keeps the leading diagonal and swaps everything else. So we have 1, 5, 9 on our leading diagonal, and we swap the 2 and the 4, swap the 3 and the 7, and swap the 6 and the 8. And that is it transposed. So now the steps to inverting a 3x3 matrix are: you need to find the determinant of the matrix, form the matrix of minors, form the matrix of cofactors according to the lattice of plus and minus, which we saw earlier, write down the transpose of the matrix of cofactors, and then we see the formula, which is the inverse of m equals to 1 over the determinant of m, with CT, which is the transpose of the matrix of cofactors. So we divide it all by the determinant. Okay, so now I've written down an example of actually doing this. I didn't want to talk through it because that would take too long, so I'm just going to talk through how I did it here. So here we have the matrix A, and so first I did the determinant, and I do want to say that if there's a 0 in one of the spaces in the matrix, you should do the determinant that has that 0 in. So I chose the one on the left, which was 1, 0, 2, but I could have also done 1, 1, 0, or anyone that has the 0 in, because it's just less work on the determinant, because you don't need to include something that's times by the 0. And this one, because I did 1 and 2, they were both positive. So I worked out the determinant of A, which was minus 1. And then, so the matrix of minus with that would be 4 times 0, which is 0, minus 1 times 1, so positive 1. And you do that for every single one. And there's the matrix minus, so there's 1 minus 2 minus 8, 1 minus 2 minus 7, minus 1, 1, and 4. And then you have to make the matrix of cofactors by timesing it by the lattices of plus and minuses. So you end up with 1, 2, minus 8, minus 1, minus 2, 7, minus 1, minus 1, and 4. And then you have to transpose it, so you keep your leading diagonal and swap everything around it. And then the final thing is to divide it by the determinant, which in this case is minus 1. So 1 over minus 1 is just minus 1. So I just times everything by minus 1, which is minus 1, 1, 1, minus 2, 2, 1, 8, minus 7, and minus 4. And that is the answer. So that is the inverse of matrix A. Okay, so now I want to talk about solving systems of equations using matrices. So you can use a 3x3 matrix to solve a system of 3 simultaneous linear equations in 3 unknowns. So if A times matrix xyz is equal to V, then matrix xyz is equal to the inverse of A times V. This is hard to visualize without an example, so I took an example. So a colony of 1,000 mole rats is made up of adult males, adult females, and youngsters. Originally, there were 100 more adult females than adult males. After 1 year, the number of adult males went up by 2%, the number of adult females went up by 3%, the number of youngsters went down by 4%, and the total number of mole rats went down by 20. So I've already solved this question for time, and I just want to explain to you how I did it. So I let x equal to the adult males, y equal to the number of adult females, and z equal to the number of youngsters. And I made 3 simultaneous equations with those letters. So we know originally we had 1,000 mole rats. So x plus y plus z is equal to 1,000. We know that there were 100 more females than males, both adult. So x minus y is equal to minus 100. And we know how much the percentages went up by. So 1.02, 1.03, and 0.96 is equal to 980 because the number of mole rats went down by 20 due to the percentage change. And then you turn those into matrices, basically. And then, so the first matrix with the numbers, you find the determinant of, and you do the inverse. So there, I've called it matrix A, which means the inverse is a to the minus 1, or the inverse of A. And if you remember what we saw before, if matrix A times matrix xyz is equal to V, then the inverse of A times V is equal to matrix xyz. So that's what I did. So matrix xyz is equal to the inverse of A times matrix 1000 minus 100, 980. So you times the inverse of A to 1000 minus 100, 980, and you get xyz is equal to 100, 200, and 700. And that's your answer. And then you write it as there were 100 adult males, 200 adult females, and 700 youngsters originally in the colony, because that's what the question was asking for. So the final thing I want to talk about is that you need to be able to determine whether a system of 3 linear unknowns is consistent or inconsistent. So consistent basically means that there's at least one solution or one set of values that satisfies all the equations simultaneously. If there's not, then it's inconsistent. And a way to visualize this is by taking the 3 linear unknowns as planes. So if all 3 planes meet at one point, it's consistent and only has one solution. Whereas if they form a sheaf, that means there's one infinitely long line where they meet, and that means there's infinite many solutions. If they form a prism, which is like a triangular sort of shape, then it's inconsistent, there's no solutions. If 2 or more of the planes are parallel and non-identical, then the system of equations is inconsistent and there's no solutions. And if all 3 equations represent the same plane, then it's consistent and has infinitely many solutions. And that's all you need to know about matrices. Thanks for watching. Bye!